Assalamualaikum and a very good day. Salam sejahtera. Assalamualaikum kepada para pelajar BNN yang mengambil subjek Process Instrumentation. Today we'll venture into chapter 4, which is part of the topic for this course, which is sensor and transducer. Memandangkan topik sensor and transducer ni agak luas. Jadi saya mengambil keputusan untuk memecahkan topik ini kepada dua bahagian, which is part 1 and part 2. For today, we will venture into sensor and transducer part 1. Okay. In this topic, for part 1, sensor and transducer, we will learn about the selection of transducer. So about this, we will know what is the parameter or what is the criteria for you to choose any transducer that available in the market. Okay. And number 2, what we will learn from this chapter is that we will know what type of sensor. There are a lot of sensor, so there are different sensor can be used in different application. And then number 3, what we learn from this chapter is the application of pneumatic and electrical signal and in process industry, which is very critical in this topic. The number 4 that you learn from this topic is the comparison between sensor. So each sensor have their kelebihan dan juga kekurangan. So from in this chapter, you will know, and then you can also be able to compare at the end of the chapter between each sensor, which sensor is good for specific application. So from this you can determine what type of sensor can be used for specific application that you wanted. Selection of transducer. The introduction of transducer. As you know, transducer is a measurement system or quantity being measured. However, it cannot be displayed. In such situation, the accurate measurement of a quantity is usually done by converting the related information or signal to another form, which is more conveniently or accurately displayed. So, this is the importance of transducer. You get a signal, however, the signal cannot be interpreted, and then you need to be converted into other form so that you can, from the form that you converted, you can actually analyze what is the signal actually indicate. Okay. Point number 2, this is achieved with the help of device which is known as transducer. So transducer, it convert unknown signal into a known signal, which enable you to interpret what the signal give you indication. Okay. Point number 4, a sensor senses the condition, state and value of the process variable, which reflect the output of the instrument. So when you're looking in any plant, for example, latex plant, for example, there is a lot of chemical reaction, exothermic or endothermic reaction that happen. And then from this, every stage, there is a sensor to determine what is the condition, what is the state, and the value of the process variable. And then from this, the transducer will change the signal from unknown variable into known signals, which can be interpreted by process engineer. So the transducer is a device which provides a usable output in response of corresponding input, which may be physical or mechanical quantity, property, or condition. More precisely, you can also interpret or you can also define a transducer as a device which transforms energy from one form to another. This is another definition of transducer. The transducer may be mechanical, electrical, magnetic, optical, chemical, thermonuclear, acoustic, or combination of among two or more. So there is a lot of transducer. It can be a combination between this. It can be a combination between mechanical or electrical. It can also be a combination between mechanical, electrical, and magnetic transducer. So it depends on application. So depend on the application whether it can be used in any field. So the end application will determine what type of transducer that you need, and then what combination of transducer that you need to get the signal and transform it into a signal that they can be interpreted. So all forms of transducer have more merit and demerit, but most of the shortcomings have been overcome with the introduction of electrical transducer. So as the progress of development of transducer, there's a lot of advantage and disadvantage of transducer. However, recently, the disadvantage of transducer has been overcome by the introduction of electrical transducer, which is very significant in process instrumentation. The most instrument system having non-electrical input quantity, and this non-electrical quantity is generally converted into an electrical form by a transducer. So, the non-electrical input yang you get from the plant, any process in the plant, it will be converted by the transducer into a electrical form. So that the signal can be captured, and then the signal also can be converted into a parameter that you can analyze. Selection of transducer. So the following are the basic requirement of a good quality transducer. So when you're working in any plant, after you have graduate, you need to take this basic requirement when you are choosing a transducer that can be used in your plant. Okay. First thing first is the roughness, meaning that your transducer must able to maintain its function, although in harsh condition. Number five, number B, linearity, no histories. D, repeatability. So your transducer must have the repeatability characters, good repeatability characteristic. E, characteristic yang kelima, high output signal quality. So your transducer must have a high output signal quality. F, high reliability and stability. So this is also one of the characteristics of a good quality transducer. Good dynamic response, and last one, no deformation on removal of input signal. So this is the basic requirement that you need to consider when choosing any transducer that can be used that to be used in your process instrumentation during plant process. There are a lot of transducer in the market, so the transducer is being classified into this. Okay, the first point, the transducer could be classified in several ways. This classification could be on the basis of their application. Okay, so the end application or end use of the transducer will will determine what type of the transducer is. Okay. Method of energy conversion, the nature of signal output, and according to whether they are self-generating or not. So this is also how you classify the transducer. Instead of not only you classify the transducer based on the application, but also you classify the transducer based on how they convert the energy that they are being collected, and then the nature of the signal output, how is the nature, and how they are self-generating or the externally power unit. Okay, so basically speaking, the transducer can actually be classified broadly as first primary transducer and secondary transducer, analog transducer and digital transducer, active transducer and passive transducer, transducer and inverse transducer. So from the classes here, you can see that there is a pairing between each transducer. For example, like primary transducer, the pair is secondary transducer. So it's easy for you to classify the transducer. Okay. So we will go one by one. What is actually the classes of transducer are? So the first classes of transducers are primary and secondary transducer. What are they? Okay, the primary and secondary transducer are transducer that directly sense the input signal and convert the physical property into electrical property. Okay, so once you convert the physical property into electrical property, it is known as a primary transducer or a sensor. Okay, so An example of primary transducer are thermistor. Okay, it's an example of primary transducer. Okay, how the thermistor works? Okay, the thermistor works via this fundamental. It sends the instrumentation and process control temperature directly and causes the changes in the resistance with respect to temperature. So the once it get the input from the process control and the instrumentation in terms of temperature, it will change it into as resistant and then with respect to the temperature itself. On the other hand, if the input signal is sensed first by some detector or sensor and its output, which may be in the form of some form of the input signal, is given as input to another transducer for conversion into electrical form, then such transducer is called as secondary transducer. Okay. Because what? Because what is known as secondary sensor? Because the first signal is being sent at, ataupun is being detected by the sensor first. So the sensor ni apa? Sensor ni actually referring to the primary transducer. So that's why after the input is already being detected by the sensor, and then the input to and then input itu is being given to another transducer for conversion into electrical form, then the other transducer is known as secondary transducer. Okay, analog transducer and digital transducer. What are they? Okay, the output from transducer may be a continuous function of a time, or it may be in discrete function of time. On this basis, the transducer may be classified into two categories. Okay, a transducer which convert input signal into output signal in continuous function of time is known as analog transducer. So the keyword is that the transducer convert the input signal into continuous function of time. So it's known as analog transducer. Linear variable differential transformer or LVDT and thermocouples are example of analog transducer. So if you're working after this, when you graduate and then your superior asks you what are the example of analog transducer, you can give that LVDT and also thermocouple are example of analog transducer. Because of what? Because it change the output of the signal in as a continuous function of time. Okay. On the other hand, a transducer which convert input signal into output signal in the form of pulse. Example, it gives discrete output is called a digital transducer. So if you get the output signal as a pulse, okay, so it's known as a digital transducer. The digital transducer are becoming very popular and useful because the digital signal can be transmitted over a long distance. So it is the merits of the digital transducer compared to analog transducer. The distance of the how distant of long distance of the input can be transferred is very long with minimum distortion, which mean there is different halangan yang mengganggu when this signal is being transferred due to amplitude variation and phase shift. Okay, this is an example in the form of diagram, the difference between analog and digital transducer interface. Okay, for analog transducer, the interface will look like this, and for digital transducer, the interface will look like this. So you can see the difference lah. Okay, that's why I give you example of analog and digital wash. Okay, analog wash ada jarum yang menunjukkan stages-stages yang berlaku. Okay, volt yang you dapat. However, for digital digital transducer, you will get in the form of angka instead of jarum yang menunjukkan indication of the volt naik. Okay. So this is the third class of transducer, which is active and passive transducer. On the basis of method of energy conversion, used transducer are classified into following two categories. A transducer which develop its input in the form of electrical current or voltage without any auxiliary force is called active transducer or self-generating transducer. The energy required for this absorbed from the physical phenomenon which is measured. Okay, this type of transducer draw energy from the system under measurement. Okay, example are thermocouple, piezoelectric transducer, photovoltaic as cell, etc. Such transducer normally give very small output, and so amplification of the signal become essential. Okay. Externally powered transducers are those which derive the power required for energy conversion from an external power source. So the externally powered transducer, they get their power from the external power source. An electrical transducer in which electrical parameter like resistance, inductance, and capacitance change in the input signal is called a passive transducer. So the passive transducer, the electrical parameter like resistance, inductance, and capacitance, it change. We change in the input signal. Okay, that's why it's known as passive transducer. They may also absorb a little power from the process variable being measured. So the passive transducer ni sometimes it can also absorb a little power during the process variable. Okay. Resistivity, inductive, and capacitive transducer, potentiometric device, differential transformer, etc., are also known as passive transducers. So when you ask what is the example of passive transducer, this is the example of passive transducer. Inverse transducer. Okay. A transducer is generally defined as a device which converts a non-electrical quantity into an electrical quantity. So this is basic definition of any transducers. It converts non-electrical quantities into an electrical quantity. Why? Because it converts unknown signal into known signal which can be interpreted by you. Okay. An inverse transducer is a device which converts an electrical quantity into a non-electrical quantity. So it inverts the process from electrical to non-electrical. Okay. A current carrying coil moving in a magnetic field is an inverse transducer. Okay. Because current by it is converted into a force which causes translational or rotational displacement. So, current which is being carried in a coil moving magnetic fields is an inverse transducer because the current is being converted into a force because the current electrical quantity being converted into a force which is a non-electrical quantity. So, this is why it's known as a inverse transducer. The most useful application of inverse transducer is in feedback measuring system. An actuator is an inverse transducer at it having an electrical output and a low power non-electrical output. A piezoelectric crystal also acts as an inverse transducer because when a voltage is applied across its surface, it changes its dimension, causing a mechanical displacement. So, a piezoelectric crystal is also an inverse transducer because it converts the electrical quantity into a non-electrical quantity. And then we venture into how you're gonna select because there are a lot of transducers available. There are many classes of transducer. So how you are gonna select the transducer? So in this chapter, which is chapter subchapter of selection of transducer, you will be exposed on how transducer are being selected based on their characteristic. So in this slide, we venture into the characteristic of transducer. Okay. Performance criteria of the transducer are based upon certain set of characteristics that give a meaningful description of quantity of measurement. Okay. Normally, these characteristics of measurement system are those that must be considered when the system or instrument is used. So, this characteristic you must take into consideration. Okay. All these characteristics have to be taken into account when choosing a transducer for any application. Okay. So okay. What are the characteristics? Okay. The characteristics of transducer are described as below: input characteristic, transfer characteristic, and output characteristic. So these characteristics you must take into account when choosing a transducer for any application. You must remember this: the input characteristic, the transfer characteristic, and also the output characteristic. Okay. What is the input characteristic? Okay. The input, there are many input characteristics. Some of them are type and operating range of input quantity and also loading effect. Okay. The first consideration for the selection of a transducer is the input quantity, which is to be measured, and its range of operation. So this is the first consideration. Okay. The type of quantity is generally known in advance. Okay. The full operating range of transducer is an important factor in the choice of a transducer for a particular application. Okay. The maximum value or the maximum limit is decided by the transducer capability, whereas the minimum value or range or the limit, lowest limit, is normally determined by the unavoidable noise which may originate in the transducer during measurement. So sometimes when you are doing your measurement, okay, when the transducer are doing the measurement to detect the signal, there are some unavoidable noises which may be originated during the measurement. Okay, a good resolution is required throughout its operating of a transducer. That's why you need a good transducer with a good resolution so that you can separate the unavoidable noises. Okay. The input, another type of input characteristic are the loading effect. What is the loading effect? Okay. In an ideal transducer, you must remember, ideal transducer means that the transducer which is very good, very perfect transducer, there is no loading effect on the input quantity being measured by the transducer. So meaning that for very ideal transducer, perfect transducer, there is no loading effect on the input quantity. Meaning that during the input quantity, there is no loading effect, okay, measured by the transducer. However, practically it may not be possible. However, during practical application, we will know the loading effect still present, so it's not possible to get an ideal transducer. Okay. The magnitude of the loading effect is expressed in the term of force, power, or energy obtained from the input and the quantity. So how you expect the loading effect based on in term of force, power, or energy that you gather during the input quantity. Okay. Hence, the transducer which is selected for a particular application should be ideally extract no force, power from the input quantity. So when you are choosing an transducer, you must get transducer with a low loading effect because you doesn't want the transducer to extract the force or power during the input of n quantity. Okay. Otherwise, you will get a mixed signal when which is which will of course give difficulty doing for you to interpret what is the signal that you are from the output. Okay. Transfer characteristic. Okay, so how does transfer characteristic works? Okay, transfer function is defined as relation between the quantity input and output and describe the input and output behavior of the system. Okay, so you get input and then the transfer function will after the transfer function you will get the output. Okay, where QO and QI are respectively output of the transducer. Transfer characteristic. Okay, sensitivity. The sensitivity of transducer is the ratio of change of output for a given change in input. Okay, in general, the sensitivity of the transducer is not constant and is dependent upon the input quantity Qi. In some cases, the relation between output and input become linear. If the sensitivity is constant over the entire range of transducer, it should be defined as below. Okay. So the inverse sensitivity is called scale factor. So how you determine the scale factor? Scale factor is equal to 1 divided by the sensitivity equal to the changes in the output in the output quantity and also the end reading divided by the output quantity. Okay. Okay. Error. Okay. Many of the time, the input and output relationship given by this equation is not followed by the transducer. Okay, so you must remember that sometimes in real application, the input and output relation is not being followed by the transducer. In such case, error is obtained in transducer. Okay, let a particular input, uh, also known as Qi, ideally the output will be Qo, but practically an output Qo is obtained, then the error of instrumentation is being represented is in the equation. Okay, the error could be due to any of the following: scale error, dynamic error, error on account of noise and drift. So you must remember that take into consideration there is also an error during the conversion of signal, okay, in transducer, and then the error can be scale error, dynamic error, or error on account of noise and drift. Okay, what is scale error? Scale error can be subdivided into zero error, sensitivity error, hysteresis, and non-conformity. Okay, what is zero order? Okay, in such type of error, the output deviate from the original value by a constant factor over the entire range of the transducer. So during the zero error is actually during the entire range of the transducer, that when it get the signal, there is the output that you get deviate from the original value by a constant factor during the entire range. Okay, for the sensitivity error, the error occur when the observed output deviate from the correct value by a constant value. So the output deviate from the correct value by a constant value. Okay. Okay. You must, okay. If you refer previously, okay, the zero error, it deviate from the original by the constant factor. Okay. However, for the sensitivity error, the output deviate from the correct value by a constant value. So you must remember this one. Zero error, constant factor; sensitivity error, constant value. Okay. For another type of error, which is hysteresis, the effect of hysteresis is obtained in all transducer. Okay. The output of transducer not only depend upon the input but also upon the input quantities previously applied to it. So different output is obtained when the same value of input quantity is applied, depending upon whether the input is increasing or decreasing. And then another type of scale error is non-conformity. When experimentally obtained transfer function deviate from the theoretical transfer function for almost every input. So during every input that you get, there is a very uh, yang menampakkan very clear deviation from the transfer function from the theoretical transfer function, okay, during every input. So this is known as non-conformity. Okay. There is also dynamic error and noise and drift error, which is another type of error that you will encounter during transducer application. Okay. What is dynamic error? Dynamic error is a type of error when the occur when the input quantity is varying with time. So you get a lot of input quantity that vary with time. Okay, this type of error occur where system contain energy storage element, and due to this output cannot follow input exactly. So you get a variable in the output because it cannot follow the input because the system have a characteristic of energy content. That's why you get variables. Okay. The dynamic error can be made small by having a small time constant. So how you are going to minimize this error by installing the small time constant. Okay. The other type of error is a noise and drift error. Okay. Noise and drift errors signal originating from the transducer vary with time and are superimposed on the output signal. So the noise and drift error it will vary with time, and then at the end it will impose superimpose, meaning that it will overlap on the output signal and causing disturbance to the signal. Error to the change of frequency. This is also a type of error. Okay. A sine wave input in a linear transducer, a sine wave output obtained. As the frequency of the fine sine wave input is increased, the transducer is required to respond more and more equally. So you need a more transducer which is more dynamic because it need to respond to the changes in the sine of wave input. Okay. In this process, beyond the range of a particular frequency, the transducer can no longer respond with respect to its sinusoidal input is changing. So at the end, you can when the frequency is keep changing, the transducer can no longer accommodate the response. Okay. Therefore, the output of the transducer becomes smaller as well as the phase shift between the input and output increase. So it becomes less efficient. Okay. Hence, the frequency increases, the output of transducer decreases. So when you increase the frequency, the output of transducer decrease. So this is caused by the error due to the change of frequency. Okay, output characteristic. Okay, for the output characteristic, they are you can consider there is a lot of characteristic. Okay, so the output characteristic are considered as given below. Okay, type of electrical output, output impedance, and the third one is useful output range. Okay, for the type of electrical output, the output of transducer may be a voltage current impedance or a time function of these amplitudes. Okay, the above quantity may or may not be acceptable to the later stage of the instrumentation system. Okay, there is a possibility to change this magnitude or change in their format by signaling conditioning equipment for making them drive the different stage of the instrumentation system. And then another type of output characteristic is the output impedance. Okay. In ideal transducer, the value of the output impedance should be zero. So in any ideal transducer, the output impedance should be zero. But practically, it is not possible, and therefore its value should be kept as low as possible to minimize the loading effect. So the output impedance should be kept as low as possible its value to minimize the loading effect. Okay. The output impedance given the information of amount of power that can be transferred to the further stages of the instrumentation for a given output signal level. The value of the output impedance is low compared to the forward impedance of the system. The transducer behaves as a constant voltage source, provided as voltage is the output of the source when the forward impedance is high as compared to the output impedance of transducer, it behaves as a constant current source. The third output characteristic is the useful output range. The output range of a transducer is limited by a noise signal at the lower end, which may shroud the required input signal. The output range can be increased by adding of amplifier in the transducer in some case. So how you are going to increase the output range? By introducing amplifier in the transducer, you amplify the signal. Okay. The addition of amplifier also increase the noise level. So the application of amplifier also have a side effect. It will increase the noise level, which is known also as an error. And therefore, in such situation, the amplifier should be avoided. So kalau you nak increasekan the signal that you get, the output signal that you get, you introduce amplifier. However, if the amplifier also increase the noise level, which is also increase the error of the transducer, so you need to avoid the use of amplifier. Okay, must remember this. Okay, so for today's lecture, I will end this lecture in slide number 22. So we will proceed with slide number 23 in the next lecture. Okay, so I hope you can go through the lecture note afterwards, which I will share with you, and then you can also uh, play my recorded video to give you better understanding of what is actually the transducer is, and their application, how it's being selected, and also type of error that's being already being explained to you in this subtopic. Okay, till we meet again in the next lecture. Have a nice day, stay safe and stay strong, everyone. Okay, assalamualaikum and a very good day.